So using the ATMEGA328P as a barebone or Arduino definitely decrease the overall power consumption that is used compared to the Arduino Uno. That is because again we scrapped out the other IC components that found in the Arduino board, and as well as the power regulators and the USB communication. So we just basically use an external oscillator, or if you opt to use the internal oscillator, and also a couple of capacitors. But there is much more efficient way on you can further step down the power consumption. That is by using the deep sleep method. So as you can see here is a code which I do not own. This is actually found in the GitHub, and all credits to this code is from Ralph Bacon, Mr. Ralph Bacon from GitHub, and he provided this code to demonstrate the deep sleep method in the ATmega 328P. So there are a couple of libraries that you want to first include, which are the avr-sleep.h and the Watchdog timer. So basically, uh, in this code, we want to let's say in your project you want to use you want to keep on an update of your let's say a temperature sensor or a humidity sensor in your room for every 8 seconds, 2 seconds, or even 1 minute, um, instead of like have a CPU loop or a BC loop, by using delays, you can substitute that time to allow the Arduino or the Atmega 328P to rest by using the deep sleep method. So all of the things that I've said will make sense upon examining this code. So first, again, include these libraries right here, and for the sake of this demonstration, we'll be using an LED to let's say every 8 seconds it will flash an LED for flash the LED twice, then sleep again. It will allow the Arduino to sleep again for 8 seconds, then flash the LED twice. So um, again, define that variable LED, and we will have a counter for our sleep. So again, I'll be talking about that later in how this variable come into play. So you can actually just scrap out this serial begin because we will not be using a serial communication. I mean yeah, serial monitor, and we set this LED pin to low, and pin mode to output, and yeah, we will not be using the serial monitor, and basically we want to flash our LED twice, yeah, just to show that the code is running. And then um, again, if you are working on the analog I mean sensors and such, you want to save the analog digital converter register, um, yeah, conversion value, store it into the this I mean to this static variable right here, just to save the yeah that current value, because again later on we will allow the Atmega 328P to sleep. So this will also like also reset all the values. So save that into a variable, and then by reset you will equate it into 0, and then we then set sleep mode. So there are a couple of different sleep modes that we want to use. So I'll be using the power down. So yeah, this essentially just essentially just yeah, basically during sleep your Arduino basically uses very small current that it is, yeah, it just like it's turned off. And the sleep enable, you want to enable the sleep mode, and then right here in this while loop, we again our sleep count is currently 0, right? yeah, it's currently 0, so it will go into this while loop. And first things that it needs to do is to turn off the brownout detection. Again, we don't want to the brownout detection to interfere with the this scenario. So in cases of like low voltage, it will like automatically reset, but not in this case. We disable that one. And then first we just disable the interrupts. We don't want to interfere again with the process of the deep sleep mode. And uh, and here we are configuring the watchdog timer. So uh, basically in this code block we set our watchdog timer to 2 seconds. So like for 2 seconds only. And then we reset it, and then again we will not be needing these messages, and then we will then allow interrupt. So whenever the watchdog timer reaches to 2 seconds, it will then generate an interrupt, and then it will go to this interrupt service routine function right here. And it will basically, first we need to disable watchdog timer, and then we will sleep count. So again, if we would say 8 seconds, we want to flash the LED twice, then sleep again for 8 seconds, then flash the LED twice. So again, our watchdog timer is limited only, so just use the 2 seconds like timer interrupt. And then uh, again we have this condition in the while loop that um, it will it will basically cut off sleep if it reaches 4 or above. And this will allow to enter this code right here to sleep, to disable the sleep. And then yeah, print this one, but again we will be not showing the serial monitor. And reset the sleep count, and also re-enable the ATC value. And then it will then light this LED right here. So again, during the sleep it will actually just stay right here until again the watchdog timer uh, is uh, is like called. And once the value right here also yeah, the value right here is also again reaches to 8 seconds. So again, if you want to make it 10 seconds, every 10 seconds you just replace this to 5. And then yeah, it will then light the LED going back here above. So yeah, the point is again, whenever the CPU sleeps, it will just stay here. It will basically, the code stops, and yeah, it will sleep. And again, whenever um upon your preference which time it will awake, it will then proceed to this part of code by disabling the sleep, and then yeah, ultimately do the code right here. So it's not necessarily you want to like blink an LED in your project or application. You might be uh, want to read a certain value time to time, like again for the temperature and such. So just insert the code it right here, and then yeah, that's basically it. Again, this is the function. It will just blink twice. So um, we will measure the current, or the yeah, the current consumption, power consumption on when running this code. So again, uh, before that, I want to compare the power consumption whenever we use the 16 megahertz clock from for the ATMEGA 328P compared to the internal 8 megahertz clock. So first, let's configure again. Let's revert back to the using the 16 megahertz clock source. So again, the value was all F to select the 16 megahertz clock, the external clock source. So just enter that one. So now that it's written, let's get back to the circuit, and let's use a multimeter to measure the overall power consumption. So as you can see, we just uploaded the deep sleep example, into our ATMEGA328P. And as you can see, for every 4 seconds, I don't know if you can see the blink, but yeah, it blinked twice for every 4 seconds. So it is actually in 4 seconds. So I had a mistake while explaining the code, and the Watchdog timer actually configures to interrupt for every 1 second. So, and our while loop condition was that for if it reaches let's say 4 seconds, it will then blink twice. So forgive me for that. And well, anyways, now that we have got the deep sleep for the ATMEGA 328P, so we should expect that it really consumes really small amount of current. And to find that out, we should let's get our multimeter and test the current rating. So before that, we will get rid of this Arduino Uno because again, it will just act as a programmer. And let's power our ATMEGA 328P with our let's say you have a battery right there to really test out the yeah, the current rating. Because the thing with this is that again, as you can see, the Arduino Uno has a some light LEDs on board, and that could also consume current. So if our goal is to really cut off current as much as possible, so again, let's get rid of these SPI programmer connections, and as well as the power from the Arduino Uno. And then and also the reset. So now prepare your battery or any power supply source. So let's power our circuit. So as you can see, it blinks obviously. So let me get my multimeter. Let's measure its current rating. So as you can see, I have my multimeter right here, and as you might have known, before you test your multimeter, you gotta make sure that your probe is inserted to a current measurement slot. So as you can see, this multimeter is pretty old, but I've inserted into a the milliamps scale, because I'm pretty sure that this won't reach to like even 1 ampere. So let me just yeah, if you don't know again how to measure the current, what you need to do is basically insert the multimeter in series with the any of the line. So again, let's just get off with this power source. Let's basically insert the so I've inserted a jumper wire so that we have space to insert our multimeter, and let me just set it to the DC current measurement. So what you need to do is also the direction right here is quite important, so that not necessarily, I mean, the multimeter can handle both direction. So just it's a better practice to always practice the convention. I mean, from the voltage source, from higher potential to the lower. So as you can see, it's actually yeah, milliamps, and as you can see, this the current measurement is pretty low. So in deep sleep mode, so during its deep sleep, it only consumes like 50 microamps. So you can see the lowest it gets is 330, and you might wonder that why does it spikes to like 7 milliamps. It's because whenever we light our LED, we basically also we consume current. As you can see, this LED has needs some current to light up. So but that's the only time. Those time, I mean, whenever it's spiked, that's the only time it really consumes. Not really a lot of current. Like 7 milliamps is really low, or 6 milliamps. But most of the time, in its deep sleep mode, it only um, like consumes like, yeah, like around 30 microamps. So which is really fascinating. And if you run this, if you, in your battery power project, uh, especially if you're using a deep sleep, it could run like for weeks or even months. So now we could really um, get ourselves right here, because we are using the 16 megahertz source. So we can even further step down the current consumption by enabling the internal 8 megahertz clock source. Not we will get rid the 16 megahertz clock source, and that will really essentially drop down the current rating compared to this one with 16 megahertz clock source. So let's test it out. But of course, we still, again, this is in external clock source selection. We configure the low fuse byte. We select the external clock source. So let's get on to the avrdude and we configure it again back to its internal 8 megahertz clock source. So now we're back here in our command prompt to execute the avrdude. Again, we want to test out the current consumption while we are using the internal 8 megahertz clock source. So in order to do that, again, we just go on to the directory of the avrdude and then execute this. Let me just zoom in. Don't worry, again, I'll just paste this command in the description below. So yeah, just run this one. Again, we Arduino was configured as a programmer, so instead of the, yeah, we name it to SDK 500 version 1. And yeah, and again, the low fuse byte value was 0xf2 if you want to select the internal 8 megahertz clock. So upon entering that, make sure that it says this command right here, if uses okay, just means that it is the code is executed well. And you should see that your blink, I mean the deep sleep sketch is running, and as you can see that it will, the speed is half compared to the 16 megahertz. So let's get back onto the circuit. So we just uploaded we just configured the low fuse byte to select its internal 8 megahertz clock source with the ATMEGA328P, and as expected, the LED blink is quite pretty slow compared to when it was configured to the 16 megahertz. So yeah, it doesn't really blink twice as fast as it was before, but rest assured that whenever you like in the Watchdog timer, again, we configured it to interrupt for 4 seconds. I mean, for a second, but we have a counter there for like if it reaches 4, it will then blink the LED. But yeah, rest assured that it won't multiply to 2 the 4 seconds. It's because we configured it to its internal Watchdog timer. It's not um although it's not quite relevant to the clock source being used. So it's still 4 seconds. 4 seconds it will sleep, deep sleep to be specific, then it will light the LED. And now let's check its current consumption. So again, let's get rid of this Arduino connections, the ISP. Oops, I think I might just... Okay, and what else? Yeah, the reset and the power. And now let's use our battery. And again, we want to measure the current rating, so
So again, as I've said earlier, just want to insert the probes. Okay, so let's measure it. So earlier with the 16 megahertz, it just like the deep sleep just like 30 microamps. And let's see how it does compare with using the 8 megahertz clock. So let me just turn my multimeter and okay, let's test this one. I know this is not the proper way to really measure the current, but I'm really limited with the resource right here. I should have used a alligator clip. Oops. Sorry. So now let's measure the current. So let's do this. So as you can see, um, there's no drastic change, but however, when we light the LED, when we compared it before using the 16 megahertz clock source, it reaches, when we light the LED, it reaches to like 9 milliamps, but during deep sleep, it's like 15 milliamps, 15 microamps by the way. So it's not quite sure because my multimeter is really limited to the milliamp scale. So although I'm pretty sure that using the 8 megahertz internal clock source, it really it further consume less power compared to the 16 megahertz. So as you can see, it's like reaches like really low. Okay, so that's it. um, I hope I've covered all, like from building the bare bone Arduino, the ATMEGA328P, and different configuration with selection of clock source, whether we use an external 16 megahertz clock source or internal 8 megahertz clock source, and also performing the deep sleep to really um, to have to save much more energy uh, in using the ATMEGA 328P. So hope you like this video and see you soon.